Okay, when we talk about design, the word design means to create something, to develop something, uh, to be able to create a solution, right, to any given problem. And when we talk about designing an experiment, what is an experiment? That's the most critical question that we look into. So, there are four things that we will be considering in this presentation. What is an experiment? What is the systematic approach? And what is parameterization? How to design experiments, right? Now, in science, we will be covering several experiments, especially in grade 8, where we talk about physics, chemistry, and biology, since we will be dividing science into three different components, right? And all three of them, you will come across a specific question known as the design of experiment, right? And it's a very critical question in IGCSE, right? So in that case, first we need to understand what is the experiment, right? So what is an experiment? Anyone who would like to add or say something about it? Muscle, what's an experiment?
Experiment is a thing where you can test it continuously to get your answers, to get results, then you get the results.
All right. Okay, to test and to get some results, right? So true. Okay. Yes. Be a little louder. Be clear. You can come with front. Okay. I need to be able to hear you before I can understand what you're saying. Characteristics, right? Very good. Very good. हाँ वो भी आते हैं वो भी आते हैं okay that's a very good description that when we want to characterize something when we want to describe something or discuss the properties or features of any phenomenon, right? Any physical phenomenon, right? Let's say if I drop this bottle, right, onto the floor, I want to see whether it's going to bounce back or not. So I'm going to test this, right? So this is an experiment, right? So very good description. Anyone else would like to add something to it? Shami, nothing? No? Alright. So what is an experiment? What we do experiments first of all to verify something, right? So if you're given any data, any information that this happens, let's say I just tell you, I give you a statement that once a filled bottle of water is dropped, it is not going to bounce, right? So whether it's true or not, you want to test it, you want to try it. So that's when you're going to carry out an experiment, right? Okay. Similar way, now I'm going to give you another idea. Now this bottle is filled. What if this is an empty bottle of water? Is it going to bounce? Now this is, we're talking about an idea over here, right? Yes. So it's an idea. We don't have the situation right now, but it's an idea that we want to test. So for testing ideas or theories, we also use experiments. And lastly, to solve any given problem, right? For example, in your ATP alternative practical questions in the IGCSE or in grade 8 checkpoint science, you will come across some problems, right? Problems relating to phenomenon or any case studies that you will get in terms of movement of objects, right? Motion of objects. So those problems we can solve them using our experiments, right? So we carry out experiments for verification, for testing, and for solving problems, right? To getting a solution. So what is an experiment? Again. conditions, data, concepts, ideas, theoretical problems, right? And by theoretical problem over here, I mean this kind of an experiment. Now, we cannot actually carry out any experiment involving sun and the earth, right? Because these are objects that humans cannot control. These are celestial objects.
So we can give our theory on them.
Yes, but we can apply our theories. Very good. Yes, we can apply our theories and test our concepts or tests. Right? So those kids, so those we call as the theoretical problems, right? And then we record the attained information. Now over here, the word record is very important. You will come across this word frequently in your exams, right? To record your observation, record your findings, right? These are the two ways that you will be or record the information. Now three of these terms are used in the questions as well, right? And then we draw a conclusion. Now remember, there is a big difference between the word conclusion and the results that we have attained. Remember, the results are of the experiment, while the conclusion is what you think is coming out of that result, right? So conclusion is the summarization or the concept that you will enforce using the results that you have attained, right? So here are three experiments. First is the artist's impression of David Scott's moon gravity experiment. David Scott was one of the astronauts who went to moon, and he threw a feather right over here and a hammer to see whether they fall the same way like the way they fall on Earth. Let's say if I have a hammer and a bird feather, I drop them all together right at the same time. Which one is going to go faster? Hammer, right? Precisely because it's heavier. But that is not the mass or the weight which is at play, unfortunately. It's not the mass that is going to affect how fast this is going to fall, right? It is actually dependent upon the air resistance that is there,
Yes.
right? And on moon, since there is no atmosphere, there is no air, both the hammer and the feather are going to fall at the same speed, unlike Earth, right? At the same speed, yes, they'll fall together, right? As compared to
I
Earth.
saw that experiment.
Yes, 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 the videos, yes, it's a very famous video, right? So I just took an artist impression. Actually, the real image was very blurry, so I had to get an image which had more resolution to it, right? So I took this artist impression compared to the real one. Okay, then we have this Celestia mathematical simulation, right? It's a simulation tool that we use to see how planets and stars and all these space objects, large scale objects, how they behave, right? So it's a software in which you can create these objects. Some of you must have played a game by the name of Solar Smash, yes, right? So it's an amazing game, it's an amazing simulator for the solar system. You can see how the revolutions of the moon are affected by the movement of Earth and the distances that are there between the planets. How the orbits are not circular entirely, they are actually elliptical in nature. So all of that you can try in a much bigger software known as Celestia, which is used to test theories, especially things like the ones that Albert Einstein suggested, right? Big theories about stars, how these things are having this power of pull towards each other, how these are pulling into each other, right? So that is what we can do with these experiments, right? So we have some theoretical experiments. An example of theoretical experiment. This is an example of an actual experiment, right? Just a thought experiment, an idea and concept that was testing, and that's our least favorite, which is the DOE experiment. Masal would know about this, right? We've seen some of these questions in our physics course in IGCSE2. So these are some experiments that we do to test what is happening, to record data, what is going to happen. For example, this diagram over here shows an electrical circuitry, right, in which we have several resistors. So we can check how much voltage is going through across these resistors, right, and how much current is being flowed. So we can take the readings from the ammeter as well as the voltmeter to get things done, right, to observe what is actually happening over here, right. Okay, moving on. What is the systematic approach? What does the word systematic mean? Forget about the word approach, just part of the word systematic. What do we understand by this word? Okay, I'm going to break the word for you. Let's just talk about the word system. And systematic means something that corresponds to a system, right? So what do we understand by the word system? What is a system?
System of like something that.
Come on, just write a word.
I can't explain. I know.
Give it a try. Give it a try.
Systematic approach, I know all and I know about it. That's something that we need to take to approach that thing that we want in the system and
Okay. Okay.
so
Then
I
next.
can.
Okay. Nothing.
Step-by-step approach,
Step by step approach. Yes.
a complete approach, how
Think
things are
that-
connected, how they affect each other.
Alright. Muscle. Same thing. You want to repeat that? Add something to it. Okay. Yes, the systematic approach means that we create a system of steps, right? We create a method, a systematic method in which, when we're observing something, we take our due time to do something. Please go ahead. Yes, sir. See, sir. Name of the boss. Welcome. Have a seat. Okay. Here's the piece of paper you need to solve a certain problem that I'm going to give you at the end of this session. Something described, right? Please go ahead. Welcome. Please go ahead. It was meaningless to draw a solution to a given problem, right? Here's a piece of paper. You're a science student, right? Okay, you're going to enjoy this. Go. Alright. So, when we talk about systematic approach, this is what we're looking into it, right? This is a bird's eye view of what an experiment is supposed to be. So, whenever we carry out an experiment, you need to understand that there is some input, right? There is some input, something that you give in, right? As an information, as a parameter, or as some, you can say a force or motion, something that you're actually trying to study, right? So that's the input. So what you give to create an experiment, right? And then we have control factors, factors that you need to control or that can be controlled, right? The word can over here is very important. These are the factors which you can control. What we usually call as fixed variables in physics, right? Or in IGCSE or checkpoint science, we will call these as control factors or controlled variables, right? Parameters that can be controlled. For example, if I drop this bottle, right, and I want to test this bouncing of the bottle, right, from the floor being filled, I can try this with several levels of water to see if the mass of the water inside the bottle is affecting how much the water is going to bounce, right? So if I do this experiment, I need to have some parameters which are fixed. Now I'm changing the water level gradually, right? So that is one variable, right? Can I control that variable?
Yes, sir.
Yes, we can, right? Now what is the second variable that we need to control in this experiment? To have a fair competition between these experiments, right?
That you are going to drop from the same height.
Yes, very good. So we need to drop this from the exact same height every time. And how can we do that? What instrument do we need to do that? Yes, a scale, a ruler, a meter rule, right? So anything that can help us measure length accurately, we need that so that we can mark a specific place or a height from where we're going to be dropping this bottle, right? Alright. So these are called control factors, right? Now there are factors which cannot be controlled. We call as error factors or noise factors, right? So variables that are not controllable, errors, right? So what could be the error in this experiment?
So the speed at the bottle with, like the speed in which the bottle is filled.
Very good. That's one factor that we cannot control, right? We can only observe it, we can record it, but we cannot control it. And that may be dependent upon the mass of this water inside this bottle, right? Now that is
There
one
can also be a frequency of wind.
resistance of the air. Yes, air resistance. But I think that is going to be the same because there is no change in wind in the room, right? So that is actually a control factor, right? We can control the wind by turning off the fans, which we already have, right? What could be another error factor in this problem? What could be the error that you can have? Any ideas? Just look at the construction of this bottle. That should give you some
The
idea.
bottle, like when it's falling, you can feel here or there.
Yes, it may tilt, it may deform, right? So the deformation of the bottle, right? It can D-shape, and once it's D-shaped, it may not act the same way, right? For example, if I drop it, first time it will bounce, but it will have deformed by then, right? And the next time I carry out the experiment, it will fall on that flat face and may not bounce. So that is an error factor that I need to rule out. That means either I need to have new models for each experiment, again converting it into a control factor, or I can just go about it as an error factor and remove it at the later if it's not affecting my experiment. Let's say if I'm just trying to evaluate how fast it will fall, then I don't care whether the bottle is going to deform or not, because I am talking about the time it will take to reach from this height to the bottom of the ground. So it doesn't matter what shape it is, right? It is not going to affect much, right? But if I'm talking about the bouncing effect, how much it can bounce off after collision with the floor, in that case, I need to be able to control this error factor of deformation, the shape of the bottle, right? That I need to control then. In that case, what we can do is that we can actually suggest a solution that we need to use new bottle with different water levels, similar bottle, but new ones, right? Every time we carry out an experiment, right? So that way we will have a fair competition between several readings, right? Several experiments of the same type, right? And finally, we get the output, right? The results of our observation, right? The results of our experiment. That's what we call as output. So understand, when we talk about output, we do not try to tamper with the readings or the observation, right? If the experiment is suggesting that what you believe in is not accurate, so you don't need to change it. Record as is, because it's the experiment that is important, not your own views, right? We will write our own views in the section of conclusion when we're trying to conclude that this is what I thought and this is what is actually happening, and this is now what I believe, right? Because the experimental data is empirical in nature, right? It can be tested anywhere else, right? Now remember, whenever you devise an experiment, you need to understand that it should have the same or similar output anywhere done in the world, right? In similar conditions. For example, if someone in India does the same experiment, he needs to have similar output. May not be the same, but very close to what you're doing, or similar in concept to what you have done, right?
Sir, to get more similar outputs, we can try the experiment 2 or 3 times to see that are the results similar or not.
Exactly. Very good. Very good. Precisely. That we need to repeat the experiment, and that is what we call as reproducibility. We will come to that in a moment. Right? Okay. In short, I can summarize the whole systematic approach to designing experiment using brainstorming, right? Discuss the idea, think what you want to do, identify the design parameters and noise factors, right? That we have discussed, the control factors and the error factors, right? Construct design of experiments, right? And this is not just experiment. We're having the word plural over here. Experiments that you need to be able to compare. As he suggested that we need to have several readings before we can come to a conclusion, and then perform the experiments, right? Actually do those experiments, and finally analyze the results. Now remember, again, I'm repeating this fact that the results do not mean the word conclusion. Conclusion is what you are going to draw considering what the results are taken from the output of this experiment, right? Any questions regarding this?
No.
No? You guys want to draw this little diagram?
Yeah, sure.
If you want to draw, if you may draw this is going to be helpful later on in science. It's very critical diagram that you will be going through in terms of your checkpoint science, right? As well as the ones who are going to be coming in IGCSE 1 and IGCSE 2 or 3, right? Let me know when you're all of you are done. No need to write the details, just draw this diagram because that's the whole summary, right? Just draw this cross diagram. Uh, Make sure that the arrows are in the right direction. I don't want the experiment going into the arrow factors, right? So, now remember the definition about the word input, the control factor, the output, and the error factors. It actually changes with case to case, right? But in general, as we speak of that, we just simply term that as the things that we can control and the things that we cannot control, or what we call as the miscalculation of irregularities, right? And either the method that we're using or the environmental factors, right? Maybe the wind, it's a windy day outside, you're trying to carry your first experiment, it was windy and then the wind stopped. So definitely there's going to be some difference in the reading, right? So that could be environmental as well, and it will actually deviate the output or the result of your experiment, right, from what you were actually supposed to expect. Okay. Moving on. Various systems of unit in use, right? Now I've taken this three base quantities, which are the length, the mass, and time. We all know this, right? Everyone knows about this. What is length? What is mass? What is time? Right? Okay. Usually we have seen this meter, right? Kilogram and seconds. Now we actually have three independent systems in the world that we use to define or discuss quantities like length, mass, and time, right? And those three systems are actually called as MPS system or the metric system that we use, right? The meters. Then we have the CGS system. I'll discuss shortly in a while. And then we have the FPS system or what we call as the American system, right? Now there is an imperial system in use as well, right? Imperial system, which is also used by Americans, but I actually distinguish American system for their FPS system rather than just the imperial system. Imperial system is very, you can see, incoherent with the FPS system. FPS system is a derivative of the imperial system. The one that is actually used in America, you won't find much of the, you can say, understanding of the imperial system. They actually call it the FPS system, right? Or what we call as a foot, pound, second, right? So in terms of CGS, we call it centimeter, gram, and seconds. And in MPS, we call it the meter, the kilogram, and the seconds, right? So this is the MPS system. Now, I'm going to give you a little problem, right? Now, you do know how many centimeters are there in 1 meter?
What's it?
How many centimeters are there in 1 meter? 10 centimeters.
Oh, 100.
100, yes. Okay. Convert 23 meters into centimeters. Quick. You've got, do it on the paper. You've got a paper, right? That's why I gave you this graphic chart, right? So you should be able to solve things and write things. So it's 23 meters, right? Okay, your answer should be 2300 centimeters. 2300 centimeters. Is that correct?
Yes.
Okay. Now I want you to convert 2 centimeters. 2 centimeters into meters. It's the other way around now. 2 centimeters into meters.
0.02.
0.02 meters?
No, 0.0.
Yes, accurate. 0.02 meters. Very good. 2 centimeters should be converted into meters. Now centimeters is a smaller unit and meters are much larger unit, right? Okay. Now we know the conversion between kilogram and grams, right? How many grams are there in 1 kilogram?
1,000.
1000 grams, right? Okay. Convert 96 grams into kilograms.
90.
96.
Grams into
96 grams into kilograms. I'm saying grams, not tons.
That is No, 0.0.
It is 96 grams. Okay? 96 grams, right?
0.096.
Yes, 0.096 kilograms, right? You just need to divide by 1000, right? Or move the decimal place 3 points back. Okay. Now we know how to convert metric system into serial system because this is the most common feature that we will see in science anywhere we go, especially in terms of your exams. You will come across these two systems. You will be using these systems, right? For natural systems or calculations, we use the FK system. But whenever a lab-based experiment, especially the design of experiment is concerned, we are actually dealing with a serial system, right? So that is why I wanted you to have some practical you can say calculation being done before we move on. In daily life, we actually use metric system. Now this is the fun thing about Pakistan. In Pakistan, actually, you will find industry which is operating in MPS system
Yes.
half of the time,
Yes.
and then they're employing the American system and half rest of
Yes,
their
one
time.
pound to one.
Now that is actually quite confusing for engineers who are working over there.